Okay, ladies and gentlemen, Mr. Kruger coming back at you. Good morning. Algebra 2 Extended, Lesson 2.2, Graphing Quadratic Functions, Factored Form continued. Basically, yesterday, what your main goal was to get the gist of how to graph from factored form, but the goal, as you can see from your homework, was being able to put your equation in factored form, which is called factoring. An absolute essential math skill. If you are not good at factoring, I have people in calculus, I was never very good at that. It's essential. If you want to continue in math, you work hard at factoring, you get it done. Your to-do list today, number one, make sure you finish up your 2.1, try it on your own assignment from yesterday. Watch this wonderful video. You might have to get some toothpicks again to hold your eyes open. Thank you. Actually, hopefully, it'll be kind of short, sweet. I don't know, I talk too much, and then when the video is done, complete the 2.2, try it on your own assignment. Okay, basically what we're doing today is given the standard form of a quadratic function, just so you know, standard form is f of x equals ax squared plus bx plus c. We're going to use factoring methods to find critical points and graph the parabola, okay? One big characteristic of a parabola, often described, is the direction that the parabola opens. This is known as the concavity of the parabola. Concavity, very important upper level math topic, okay? A parabola is concave up if it opens upward, and it's concave down if it opens downward, okay? Looking at the four parabolas we graphed yesterday, in lesson 2.1, can we make any conclusions about predicting the concavity of a parabola from the factored form of the equation? And standard form of the equation there, and then factored form. Let me come up there and say factored form of an equation is going to be a times x minus root 1 times x minus root 2. However, check out this cute little a here and the cute little a here. It doesn't matter if you're in factored form or if you're in standard form. Okay, we can always look at that a value and we can always find the concavity of the parabola. Because if you look back, anytime we had an a greater than 0, okay, that just means it's positive. It was concave up. And anytime a was less than 0, meaning it's negative, the a value, it is concave, you guessed it, down. Okay? So we're going to look at this. We're going to bebop around. So let me give you an idea. What the heck are you talking about, Kruger? Concavity. Well, I can look here. I can answer this question right away because here I can see a equals 1. I don't have to do anything to it. This is going to be concave up because a equals 1. Not because a is 1, it's because a is positive, okay? Bottom line, we're going to graph this. We're going to find the roots or zeros, x-intercepts, axis of symmetry, vertex. But the way we're going to do this, if we're finding the x-intercepts, is we are going to put this little bugger in factored form, okay? And what we're going to do is we're going to factor this because I know x times x gives me x squared. That's negative, which means one's positive, one's negative. The factors of 10 that I need to use, well, if I need a negative 3, I need more negatives than I need positives. And when I check my outer and inner terms, I can see negative 5 plus 2 gives me negative 3. I factored it beautifully. It's all factored. Once it's factored, x plus 2 equals 0, so x equals negative 2. So I have an x-intercept of negative 2 comma 0, and I have an x minus 5 equals 0, so x has to equal 5. So I have an x-intercept in factored form of 5 comma 0, and I can plot those two. So I get negative 2, and then I come out 1, 2, 3, 4, 5. And I get to 5. My axis of symmetry, the AOS equals intercept plus intercept divided by 2 equals 3 over 2 for the fraction people. So x equals 3 over 2, or for the decimal freaks, we can call it 1.5. So I can graph my axis of symmetry at 1.5, and my calibration is off a little bit. Sorry about my line. And I'll calibrate it for the next one. Once we have our axis of symmetry from yesterday, we said to find the vertex. We know that's going to be 1.5 comma something. We need to evaluate our function at 1.5 to find the vertex. So that's 1.5 plus 2 times 1.5 minus 5. Well, that gives me 3.5 times negative 3.5, which actually ends up equaling negative 12.25. So my vertex is at negative 1.5, negative 12.25. Because my graph only goes to 10, I'm going to throw a qualifier. Y scale is by 2s. Make sure you dictate that if it's there. So I can plot my vertex, and that's negative 5. I'm going to say 2, 4, 6, 8, 10, 12.25. I'm going to guesstimate it to be right about there. My y-intercept, to be quite frank, is easiest to find in standard form, because when my equation's in standard form, the c value, that's my y-intercept, because I'm putting a 0 in for x, a 0 in for x there, so I get 0 comma c. So when I look at this, I can say, hey, my y-intercept is 0 comma negative 10, which means I could plot that, say 2, 4, 6, 8, 10, and I can graph my parabola. And when you're doing this, make sure you check everything on Desmos. I'm not going to do that. I'm going to try to keep my video a little bit shorter, a little bit sweeter. Now, I'm going to have you start factoring this one as I'm calibrating my screen. I'm going to hit pause. I'm going to calibrate. I'm going to be back. Do as much as you factoring as you can there. All calibrated up. If you factored right, hopefully you picked your GCF of 2 out first to pull that out of the 3 terms, and then you continue to factor to find out your x-intercepts are going to be, I technically have 3 factors, but to find my x-intercepts, I only set factors that have an x in them equal to 0. So I got 1 at 5, minus 1 equals 0. I got 1 at 1. Okay, so I got 1 comma 0 and 5 comma 0 for my x-intercepts. So I got a 1, school's out, 2, 3, 4, 5. And from there, next thing I want to find is my axis of symmetry. My axis of symmetry always equals intercept plus intercept divided by 2. That's 6 over 2. That's 3. Remember, that's an equation of a line, so it's x equals 3. I like to graph that little devil in red all the time. I always graph, I don't know why. It's the way I was brought up. After I find my axis of symmetry, that value for x always gets used to find the vertex. So we need to find f of 3. F of 3, I prefer when I'm doing things longhand, I don't prefer that. If it's factored, I prefer to plug it into a factored form of the equation. The math is easier to do in my head without a calculator. That's 2 times negative 2 times 2. I know that's negative 8. So 3 comma negative 8. And I'm going to come right down there, I can plot that little devil. My concavity, check it out. A equals 2. There's my A there, and I can see my A in factored form as well, okay? A equals 2. So my concavity is going to be up because A equals 2. Not because it's 2, because it's positive, okay? Now, y-intercept. My y-intercept, all I got to do is plug a 0 in for x, and obviously that makes that gone, and I'm left with 10. I don't like to find my x-intercept over here as much. It's a little bit more math. So I try to take the path of least resistance. So I'm going to go 10, 1, 2, 5. Oh, 10's way up here. So I'm going to, this is a really skinny guy going up. And it's going to kind of come up. Boom. There it is. And that one's graphed. And we got number 3 yet. So we're coming up to number 3. Hey, why don't you hit pause here a second, and why don't you try to factor it? All right, so boom, boom. GCF. Yes, there is a greatest common factor of negative 3x. When I take a negative 3x out, or negative 3x times what gives me negative 3x squared, and x, negative 3x times what gives me negative 15x. That would be a positive 5, okay? That's just how you take a GCF out. I'm in factored form. I actually got two factors. So I'm going to take the first factor, set it equal to 0. X has to equal 0. Take my second factor, set it equal to 0. X must equal negative 5 there. So I have two x-intercepts, negative 5 comma 0, and I got 0 comma 0. There they are. I can plot those. So I got my 0, 0, and I got negative 5, 0. Next thing I'm going to do is I'm going to find my axis of symmetry. These are the steps to graph from intercept form, guys. That's all you need to know. Axis of symmetry equals intercept plus intercept divided by 2. Negative 5 over 2. I'm a fraction, guys, so I'm going to leave my axis of symmetry as x equals negative 5 over 2. You decimal freaks are going to say, no, Mr. Kruger, that's negative 2.5. I don't care. Call it whatever you want. And I'm going to put my negative 2.5. That should split the seam right there. And those blue dots should be pretty equidistant. Not pretty equidistant. They should be equidistant on both sides of your axis of symmetry. Next, we take the vertex. Remember, we just simply take that value in negative 2.5. And we need to find what is f of negative 2.5. So we're going to plug that into our equation. Negative 3 times negative 2.5 times 2.5, negative 2.5, sorry, plus 5. So that is negative 3 times negative 2.5 times 2.5. And I say a positive, or a negative times a negative times a positive. I'm going to get a positive answer. And what I get when I multiply those three numbers is 18.75. So my vertex is at negative 2.5 comma 18.75. I can't fit that on my graph if these are by ones, right? So I got to qualify over here. I'm going to say my y scale is this time, because this is only 10 high, well, I could go by twos if I wanted to, couldn't I? 18.75 is by 2s. So I can go by 2s because I can fit it on there yet. It's going to be a real skinny devil, but that's okay. So I can say 2, 4, 6, 8, 10, 12, 14, 16, 18.75. So it's going to be somewhere, oop, I want blue there. It's going to be somewhere right in here. Okay, no big deal. Concavity. Hey, what is my concavity? Check it out. Here's my A value. Here's my A value again. Concave down. And that's basically because A is a negative number, okay? Concave down. What is my y-intercept? Well, I got this thing all inked up and jazzed up. So hopefully you're like, Mr. Kruger, we already found our x and our y-intercept. Hopefully somebody's saying that, because when I put 0 in there, gone, I'm left with 0. And hopefully you saw we plotted that little dirty rascal right away. So all I'm going to do is my best to graph this guy concave down. And there's a wonderful graph. Like I said, check those little rascals, those little potlickers in Desmos. And we have two examples yet, because we always have to have application problems, word problems that everybody hates, okay? Now these type of word problems we're going to see, because we're working with factored form, we will be writing our word problems in factored form, and it should make sense as we go through here, okay? At T-Mobile, a T-Mobile store sells about 70 of a new phone per week at a price of $320 each. For each $20 decrease in price, they sell 5 more phones per week. Let X, big deal here, okay? I don't want that. I want my highlighter pen, and let's see if I can find that. I want my highlighter pen because this is really important. That means when I'm writing my equation, anywhere I see X, X is the number of $20 increases. It doesn't represent the $20. It represents 1 increase or 2 increases or 3 increases, okay? Really important to differentiate that when you're looking at that. Get my regular pen back. Write an expression for the number of phones sold with X decreases in price. Okay, well, how many phones are they selling right now? Right now, they are selling 70. How many fewer phones will they sell? Well, they're going to sell, they're not selling fewer. With X decreases in price, well, obviously, Kruger, you moron, if they decrease the price, people buy more phones, so they start at 70. For each decrease they add, they're selling 5 more X times, because if they decrease the price twice, they're selling 10 more phones. If they decrease the price 3 times, they're going to sell 15 more phones, okay? Now we're going to write the expression for the price of the phone. Well, everybody says these are so hard. When they come to me, all I say, okay, how much is the phone right now? Right now, the phone is $320. Are they increasing or decreasing the price of the phone? They're decreasing the price, which means it's going to go down. How much is it going to go down? It's going to go down $20 every time I decrease it. So if I decrease the price twice, that phone's $40 cheaper. And it all blends right into that wonderful formula, okay? Note, revenue. Revenue is defined as the product, multiply, of the price of an item and the number of items sold. I know you guys knew that. All we're going to do is we're going to take, this is number sold, and this is price. So if we're writing a revenue equation, we are simply, we're going to take the price of an item times the number sold. So I can say 320 minus 20x, that's the price of the phone, times 70 plus 5x, that's how many phones they're going to sell. And if I take number times money, I get revenue, okay? No big deal. Check it out. That is in factored form. It's in factored form. But what type of function is it? Well, look at it. In the end, if I end up taking my x times my x, I'm going to get an x squared in there, which means it will be quadratic. If your biggest power of x is x squared, it will be a quadratic function. This one just happens to be in factored form. Okay, what are my x-intercepts? Just because this is a word problem, I'm not going to find my x-intercepts any different. Okay, I'm going to take one of my factors, 320 minus 20x equals 0. I'm going to solve this for 0, but I'm going to move the 20x over here because it's negative. Okay, 20x. Now I have to divide by 20. Check it out. My intercept is not 320. Okay, it's not. I got to get x by itself. So x, when I divide that, is going to be 16. So one of my x-intercepts is 16 comma 0. What's my other x-intercept? Well, that's coming from my other factor here. It's not negative 70. I got to take my 70 plus 5x. I need to set it equal to 0. Well, here I'm going to keep my x's positive, and I'm going to move my 70. Then when I divide negative 70 by 5, negative divided by a positive, that's a negative. It ends up being negative 14. So my other x-intercept is negative 14 comma 0. Okay? Wow! Check it out. How many price drops would maximize revenue? Well, if I'm looking inside here, guys, one thing I need you to see. When I take, in the end, when I take my x times my x here, okay, what's negative 20x times 5x? That's going to give me negative 100x squared, because x squared is the biggest variable in there. My a value is negative 100, right? So is this going to be concave up or concave down? Obviously, hopefully it's obvious, you're going to see it's a concave down, so my graph should kind of look like this, if I think about it. Now, if I'm maximizing something on this graph, where do you think the most money made is going to be? That's right. It's right up here at this point. What is that point called? The vertex. Okay. Now let me lay this thing into a coordinate plane. The x value, my price increases. Guess what it is? It's my axis of symmetry. So how am I going to find that? I'm going to take that by taking intercept plus intercept divided by 2. That gives me 2 over 2 equals 1. So how many price drops? Remember, x is a price drop. If I drop the price once in this particular application, I'm going to maximize revenue. Okay? What is the price that would maximize revenue? Well, here's my price. If I'm going to take my $320 and I'm going to drop the price by $20 one time, that's right, it's a $300 phone. How many are they going to sell at $300? Well, they dropped the price one time. My price of the phone, my number of phones, I'm selling 70, plus I'm going to sell 5 more for every price increase, but I only increased price one time, so it's going to be 70. Bonehead. 75 phones are sold. Okay, so I got to get my 5 in there. Now, what is the maximum revenue? What we just set up here, if we take the number, or if we take the number of phones, 75, times the price of the phones, 300, what is 75 times 300? Well, that's right, it's $22,500. Okay, now the cool thing is when I look at my graph, if I graphed this in Desmos and I saw the windows, do you know, I'm going to bring it down here, I'm going to have this graph, I'm going to have it here at 1, I'm going to have a big old vertex right here, this thing's going to be coming down, it's going to be coming down, I have my x-intercepts I found. This top part, what do you think the ordered pair of that's going to be? 1 comma $22,500. My vertex is talking about the number of price increases, how much revenue I am making on it right there. So we got one more example. I'm going to try to boogie through here, and I'm just going to hit pause and I'm going to let you read it quick, and then I'm going to start it. Okay, so as you took your time to read that, one super important piece here, it's even bold-faced. For each decrease in the length of 2 yards, each decrease length of 2 yards, he must increase width by 3 yards, okay? And X is the number of times Junior decreases length, okay? So as he decreases the length 2, it's going to increase 3. Write an expression for the length of the play area with X decreases of 2 feet. Well, what is the current length of the play area right now? The current length is 124. 124. If he's decreasing the length, how much is he decreasing the length? 2 feet every time in this case, right? Okay. What's the expression for the width? Well, currently it's 66 yards wide. So right now it's 66. Now he has to increase 3 yards for every time he decreases it. Okay? So decrease 2 yards, increase 3 yards. Write a function that describes the area. Well, you know to find the area of the play area, the frolic zone. Okay? It's a rectangle. You know it's length times width. So what I need to take is I need to take somehow, my length, 124 minus 2x, times the width, that's my length, times my width of 66 plus 3x, times my width, length times width, gives me area. Okay? How am I going to find my x-intercepts? Check it out. Even before I do it, look. What's that going to be? That's going to be negative 6x squared. Negative 6x squared is going to be my biggest power in there. So that's going to make this quadratic. Okay, the cool thing is, okay, find the volume that will maximize the area. Whoa, I didn't want to cross that out, but if we're maximizing area, okay, we should have an understanding by now. If we graph this in Desmos, I'd rather you don't do it yet, but we are going to get a graph that is concave down because A is negative. If I'm concave down, I'm going to maximize somewhere. I'm going to have a vertex that's going to be the highest point maximizing things, right? Okay. So in order to find that vertex from this form, we want to find our intercepts so we can split the seam of those intercepts so we can find the vertex, okay? What are my intercepts? Well, I have two things here, okay? I have my length. What's 124 minus 2x equals 0? 124 equals 2x. X has to equal, that'd be 62. 1x intercept is 62, comma 0. Okay? What's my other one? Well, my other one is going to be 66 plus 3x equals 0. So 3x equals negative 66. X has to be negative 66 divided by 3, negative 22. My other x-intercept is negative 22, comma 0. Boom. Okay? Now, how did we find that highest point right there? What is it on? It's on the axis of symmetry. What does the axis of symmetry always run through? My x value. How did we find that? This x value is always going to be your axis of symmetry. So how do we find that? We take x-intercept plus x-intercept. We're going to average those two. We get 40 over 2 equals 20. I'm going to decrease the length 20 times to get it to where I need it to maximize the area. Well, if I decrease it 20 times, what is my length? Well, my length was 124 minus 2, and I'm decreasing it 20 times. So what's 124 minus 40? 84 yards. Well, if it's 84 yards long, how wide is it? Well, that's coming to my width over here of 66 plus 3 times 20. Well, that's 60 plus 66. I guess that means my width has to be 126 yards. If we're going to maximize the maximum area, we're going to take length times width. What's 84 times 126? Okay, 10,584 yards. Whoa. My hand got ahead of my brain. 10,584 yards, and they are square yards because it's area, okay? Now, if you graphed it in Desmos, the coolest thing about these things, in my opinion, the ordered pair of that vertex, it's going to be the number of decreases, comma, the maximum area when I graph it. See, I'm not seeing these pieces of the puzzle in there. I'm seeing number of decreases, maximum area. How did I get these? I got those by plugging them into what the actual length and width would have been. Hopefully that helps. Any questions? Mr. Myers and myself are patiently waiting and would love to see your wonderful faces on office hours. Have a good day.